Okay, so this video we're looking at an introduction to the circle theorem. So what I'll do is I will go through all of the circle theorems, and what I recommend you do is you make a note as we go through this, because in the next video we'll look at some questions involving using the circle theorems. And if you've done this with me in class, you will know that the questions on this can get quite tricky, so we need to make sure we've got the fundamentals of circle theorems under our belts. Okay, so I'll get your notepad out and I would be ready to make some notes on this video. Before we start with the circle theorems though, we need to know some pretty key parts of a circle. So to begin with, really simple ones, the centre right in the middle of our circle, we can go and draw a radius line like this, which goes from the centre to the circumference of our circle, which hopefully that we are familiar with. We can draw a line which is double the radius, which we go and call the diameter. So the diameter goes right through the centre of the circle, and that's our diameter line. And then maybe then we've got the outside of the circle, which we call the circumference. So these are parts that hopefully we should be well versed in. Then we potentially got some new words coming up. So if we go and draw in this blue line here, going from one point of the circle to another point of the circle, but not through the centre, this line here is called a chord. Okay, so I've drawn a chord here, a bit like on a guitar, same word, a chord line. Okay, and then we actually get an area from the chord line to the circumference of this circle bit here, okay, which we go and call the segment. That is a segment. Okay, so the area between a chord and part of the circumference of the circle, we call a segment. Okay, we've also got this area over here, which is different to this area because this area is enclosed by two radii, so two radiuses of the circle. Okay, so it's a bit like a slice of a cake from a pie or something. Sorry, a slice of cake or a slice of a pie. Right, and we go and call this area a sector, which is different to the segment, okay, because it goes from two radiuses of the circle, okay, from the center. And then something new to us also, right? If I go and draw a point like I've drawn here, and I draw a line going from that point to the circle that hits the circle exactly and only at one point, and that's really important. So I draw a line from the point to the circle and they touch at exactly one point, okay? We call that line to be a tangent line. So that might be a new word for us. So this is a tangent line, and this is a really important one to know for later. And then last but not least, right, if we go and just take part of the circumference of a circle, so not the full thing, we say that this is the arc of a circle, okay? So what I recommend you do is just maybe make a note of some of those, and then we can proceed with what the circle theorems actually are. Okay, rule number one, which states this, and for all of these, right, we'll go through the rule, and then I give you some examples you can try yourself. So rule number one states, right, angles at the center, let's get our highlighter up for this. So angles at the center is twice or double the angle at the circumference. Okay, so it's just saying the angle at the center, this one here, angle B, is twice the angle at the circumference, which is this one here. Okay, so it's just about to be able to recognize this shape here. So looking at the first examples, right, it says find x. Well, we've just said that angle at the center is double the angle at the circumference, which must mean that this angle here is going to be half of 140. So 140 divided by 2, which is going to be equal to 70 degrees for that one there. Okay, and that is your answer. Yeah, it's just half of the angle at the circumference, 70 degrees. We've then got the one below, right, which actually, this is actually a really tricky variation, but they often like to ask this in exam questions and be quite sneaky about it. In fact, if you're watching this in 2024, on paper 4 for OCR, they actually had a question very similar to this one here, using the same kind of rule. This here is actually the same rule as what's going on over here. What's happened is, the reason it looks a little bit funny is you've got to imagine, and it's quite hard to imagine without simulating it, but they've taken this point, in fact, let's try and highlight it, maybe, yeah, let's highlight it. They've taken this point here, and they sort of moved it across to somewhere like this, which means that this line has moved from here originally, and because this point has moved down to over here, it's kind of now moved to go through like this. So you've got to kind of imagine that this line here is shifted down there, but it is still the same rule because you've still got, importantly, you've got 2 points going to the center of that circle. This is a tricky variation, right? I put it in there because often people neglect this one, but it's still the same rule. So if we kind of spot this one, it's just again saying really that the angle at the circumference, so that value of x is half the angle at the center. Okay, so to get this one, x this time, we've got to go and do that 87 and half it, divided by 2, which is going to be, half 87 is going to be 43.5 degrees. Okay, 87. Yeah, because the angle at the center, 87, is twice the angle at the circumference. This one is the circumference angle, so there we go. That is our answer. That is a tricky one, right, to put in there straight away, but that is the reality of what they can ask in exams, so we need to be aware of that. Okay, rule number 2 states this, which is angles in a semicircle. Okay, so, sorry, angles that contain a 90-degree angle. So we can see here we've got a semicircle because the diameter goes right through the center, so it's a semicircle, and I've drawn in a triangle like this, okay? And we're just saying that angles in semicircle, they must contain a 90-degree angle, like I can see here. So if I look at an example, okay, this one is saying, right, find the angle x. Well, it's using this rule here, this angle must be equal to 90, because angles in semicircle contain a 90-degree angle. And to find x, well, if I go and add 90, add 34, and then take it away from 180, so 90 to 34 is equal to 124. So then to get this missing angle here, x must be equal to the angles in a triangle, which add up to 180, take away 1, 2, 4, okay, which is going to be equal to 56 degrees. Okay, and that is my value of x in that question. Okay, so let's go highlight that, and that is it. Okay, so it's just about being able to recognize, if you see that, okay, we need to use this. So make a note of rule number 2. Rule 3, which is a nice one. It says angles from the same arc. So, okay, these 2 points here are coming from the same arc. So angles from the same arc at the circumference, okay, are equal. So because they're coming from the same arc here, and we've got angles at the circumference, so this bit here and this bit here on the circumference, they must be equal according to this theorem. Okay, so if that was 30, that angle would also be 30. It follows on, right, if I go and draw in another angle from the same arc, so if we go and draw that in like this, okay, this angle here would also be equal to both of those two. And you can do this infinitely many times. Okay, so that's the basic rule, but then you can add in this as many times as you like, because still, these points here are coming from the same arc. So if we look at an example, right, I found the values of A and B. This one, really, really straightforward. It's just being able to recognize what the rule is. Well, because all of these angles here, I should probably highlight it, are coming from the same arc, which is this point here. Okay, drawn in not particularly well. All of these angles here must be equal to 37. So we can just go and simply say that A must be equal to B must be equal to 37 degrees. Okay, they're all just equal to the same thing, 37. Okay, rule number 4, opposite angles in a cyclic quadrilateral add up to 180. What does that even mean? Well, cyclic just means circle. A quadrilateral is a four-sided shape, so we're saying opposite angles in a quadrilateral, a four-sided shape in a circle, add up to 180. So we're just saying here, okay, that A plus C, so this angle here, A add C, these are opposite angles, they add up to 180, and similarly, B plus D, if I highlight it in a different colour, B plus D, opposite angles also add up to 180. Okay, so if we look at an example using this rule, well, let's go and do this one here. Well, opposite angles, first of all, here, we've got x is opposite to that 50 there, so these must add up to 180. So to find x, it's just going to be equal to 180 minus 50, which is equal to 130 degrees. Okay, so that's what angle x is. Angle y, opposite to 85, add up to 180, so angle y is just going to be equal to 180 minus 85, which is equal to 95 degrees. Okay, so x, we said, was 130, and y is equal to 95. And just to double check, right, that is correct, but what do we know about angles in a quadrilateral? What do they add up to? Like a square, they add up to 360. 130 add 85, add 50, add 95, they do sum to 360. Okay, so there we go. Good. Rule number 5, probably the trickiest rule that there is, which is the alternate segment theorem, which again, if you're watching this in 2024, came up on the OCR paper 4. But this theorem states, and it's just about recognizing this one, to be honest, it states this, that the angle between a chord and a tangent, so the angle between a chord and a tangent, is equal to the angle in the alternate segment. So it's just saying, right, the angle between a chord and a tangent, so here's your chord and here's your tangent for the red angle, okay, is equal to the angle in the alternate, so like alternate angles, so kind of like other way segment. So these two red angles here are going to be equal, which I've gone and drawn in there. So these two red angles are going to be equal, these two blue angles are going to be equal. If that red one was 40, that red one would also be 40. So using an example up here, using this, right, to go and find x and y, just using the same rule here, okay, so you're just kind of spotting the similarities. Well, this 55 is going to be equal to that value of x, so x is going to be equal to 55 degrees. And then similarly for y, looking at this bit and this bit, same way there, we've got 60 and we've got y must be equal to 60 degrees. And that is it, okay? Look, you'll see in the next video that these questions can get a bit trickier, but these are just the basic rules for the time being. Okay, we're just getting familiar with what these rules are. And then rule number 6 and 7 we'll do together, which is a tangent and a radius, they meet at a 90-degree angle. And this is a really important one. This one comes up a lot. So if we have a tangent line like this one here and a radius like this one here, right, they always meet at a 90-degree angle. So similarly, right, if I went and drew in another radius like here, obviously that would be straight using a ruler, and a tangent line that meets that radius at exactly 1 point, okay, it would follow that this here would also create a 90-degree angle. And rule number 7, last but not least, we've got two tangents. Okay, so again, a tangent from the point, so two tangents to a circle from the same point are equal in length, which we can see by these lines here. So if we go and draw in a tangent from this point, which is here, and another tangent from the same point, okay, they're going to be equal in length. Okay, and that is it for an introduction to circle theorems. Hopefully that was useful. In the next video, we'll look at actually answering some questions involving circle theorems. Okay, thank you.